Now the second part of our MUG event Zurich starts, and we'll tell you something about data modeling, and the second part of my speak will cover our project we did at Helvetia, and of course Cedric knows about that. I tried, or my idea was to start with what's data modeling for database, and it depends on you at least. Do you really need that? Because there's a one-to-one, a one-to-many, many-to-many relationships. So I guess you don't need this. But I can tell you when you want. I will go very quickly about, over these slides. What's data modeling? What's data modeling for? Of course, data modeling is a very important thing, part of software development, because at least it depends on the data model how fast you can access your data and how your data are stored, and even for the visualization. So I'm sorry. Here you can see, of course, there is a one-to-one, one-to-many, and I did all this stuff. I guess you know this. Please tell me when not. I will go more in detail, but I think it's not necessary.
What are the advantages of data modeling process?
What a question. Of course, it's here. It's written here. It's of course you can do the better planning, and the implementation result is also much more better, and you can improve performance when you're doing proper data modeling. But Amelie, I guess I will do your flavor, because. But I have no idea how I can.
Go a bit down, scroll down on YouTube. You can click on YouTube. Screen there, maybe.
Thanks. Yeah, okay. Here I can.
Hey friends, deploying a MongoDB application without first considering your MongoDB schema design is a little bit like deploying to production on a Friday. Hey yo, Mog, I'm going to deploy to production.
Sorry, it's too loud, or isn't it? Is it okay? Yeah.
Say, cool? Sure, yeah, no problem. Go for it. No! What's the value in setting up the proper schema design? Make your application faster, saving money, making developers' lives easier. When most developers are coming to MongoDB schema design, I think a lot of them are coming from an SQL background, and a lot of them look at schema design a little bit like this. Corporate needs to find the difference between these two photos. Those are the same photo, right? In this video today, we're going to be discussing schema design approaches from a relational background to kind of set a baseline. Then we're going to compare that to MongoDB. After we cover that, we're going to be talking about different types of data relationships that we commonly see: one-to-one, one-to-many, one-to-squillions, and many-to-many. This video is for people who are new to schema design, new to MongoDB, or maybe they have a background in relational databases. But hopefully we can take you and bring you to the world of MongoDB schema design and taking advantage of all the cool features that you would not be able to do or use if you were using a relational database. There is a long history of research done on how to best split up data with relational database management systems. And this process is called normalization. The TLDR of normalization is we're trying to split up our data into tables in order to reduce duplication of our data. Let's look at how we might model a user data in a hypothetical application. So a user would have professions and cars we need to track with it. If we want to combine all that data together, we do something called a join on foreign keys. And in this example, you can see the user ID column in the professions and cars table is linking that data to the users table so we can run a query and pull all that data back together for us. So we're normalizing this data, and we're able to do queries that join data sets together from separate tables, so we don't have to worry about duplication. So that's the super fast version of relational schema design. Let's look at MongoDB. Let's see what we can do with that one. MongoDB schema design is a little bit different. No more rule book, no algorithms, no process, whoosh, nothing. Joe, what? How do we design a schema if there's no rules? I'll tell you the platinum rule of MongoDB schema design. Design a schema based on the unique needs of your application. Nothing else matters. Two people might be dealing with the same data, but how that data gets used dictates how you want to design that schema. Let's take that user model that we were working with the relational table, and let's convert that over to a MongoDB document. That first user table has a bunch of simple data in it. That can just be reflected as key value pairs in a MongoDB document. The professions and cars table is a little bit different. Those have more complex data structure we want to follow. And that's hard to do in rows and columns, but super easy to do with MongoDB documents. A user can have multiple professions, and that's really easy to model with a document. We can just use an array of professions and embed that directly within that user document. Similarly, with that cars table, it's very similar, right? But there's more complex data structure. We have to keep track of both the model and the year for each vehicle. But we could just use an array of objects and embed that directly within that user document. We have all the data all in one place. We don't have to do any complex, time-consuming joins. We just pull it all from one document, bada bing, bada boom, super fast and performant and scalable. I should mention here too, if you want to discuss your schema design for your application, the best place to do that is on the MongoDB community forums. Be sure to check out community.mongodb.com and let me know what your questions are. Yeah, I'd love to take a look at them. That's a link in the description below. Now let's discuss types of relationships and how we would model those with MongoDB. The first one we're going to cover is one-to-one. One-to-one makes me think about going to Target, and do you know how Target has those frozen meals for one? One Joe equals one meal for one. That's it. They're delicious. One-to-one relationships in schema design are very similar, actually. One user has one name, one company, one Twitter handle, one Twitch handle, one TikTok, one website, right? One-to-one. Let's take a look at one-to-many. One developer might have many stickers on their laptop. One me, many developer stickers. Let's say, for example, you are asked by your boss to build an e-commerce store, and we need to be tracking all of the products we're going to be selling in a MongoDB database, but we also need to keep track of all the parts associated with each product in our catalog. In this situation, let's assume that we don't need to access all of the subpart information often, so let's pull that out. Let's separate it. We have a product document that's all the metadata, but we also want to keep track of that relationship, so we have a parts array within that document. And that would have object IDs that link us to all of the other parts documents within our same collection. We could run queries then that would be able to go and pull all of the associated object IDs, and we could get all that data together. But if we don't need it very often, let's pull it out. No problem. Do you remember when I told you that we threw out the rulebook? Remember that? I kind of lied. I made up some rules to help you, dear watcher of this video, design scalable schemas for your application. My first rule, I favor embedding unless I have a compelling reason not to embed that data, right? Just look at this one-to-many relationship. And rule number 2 is also related. Avoid joins if they can be avoided, but don't be afraid to use them if they make your schema design better. Squillions is in fact a real word. I did not make it up. Squillions sounds like a fancy Welsh traditional dinner that might involve squid in some way. Squillions actually means it's a unspecified massive number. Just think million, zillion, gazillion. Imagine with me, if you will, you've been asked to build an application for logging. And I'm not talking about timber logs. I'm not talking about lumberjacks. What I'm talking about is server logs. We could potentially be generating a squillion number of events that just keep tracking everything that happens on these servers for years and years and years. The issue that we come into with this schema is that there is a 16 megabyte per document limit on a MongoDB document. And if you have an array of object IDs and you're logging, massive amounts of events, eventually you're gonna hit that 16 megabyte per document limit, and that's gonna break your application, which we don't want. We wanna make sure we're designing a schema that can handle infinite growth on some sector or application. For this example, we're gonna have a host document. And then for each log event on each of our servers, we're gonna generate a brand new MongoDB document. Each of these log messages will be responsible for tracking the host or the source server that the messages are from. If we keep track of it with this reverse reference, we don't have to worry about having an array that grows with unbounded size, and it might potentially hit that 16 megabyte per document limit. Rule number 3, arrays should never grow without bound. If I ever see a schema design that potentially could have an unbounded growth within an array, that's a massive red flag for me that we need to readdress and reconsider the schema design for that application. Let's imagine that you are building a to-do list. Each user in our application could have many to-do items on the to-do list, but also a single to-do item can be owned by many users. We're gonna be taking lessons from all of our previous schema design relationships and apply them here. We would have user and to-do item documents within the same collection, and users would have an array of object IDs that associate with the to-do items they own. But we're also gonna need to track the multiple owners, and we're gonna be doing that on the to-do items. So on the to-do item, they also have a reference to an array of object IDs of the owners who are working on that ticket. So we have a reverse reference that two-way relationship is being maintained, and we can write queries that can pull all that data out for our application. Rule number 4, needing to access data on its own is a compelling reason to not embed it. That also leads me to rule number 5, the platinum rule. Do you remember what it is? Design a schema based on the unique needs of your application. That's the only thing that matters. So we've covered MongoDB schema design and a bunch of the basics here today. If you want to get better at MongoDB schema design, what's the best way to do that? I think videos are a great place to start, but for me to truly grok a subject, I need to make sure that I am actually doing it and playing with it and trying it out. And the best way to do that is to sign up for the free tier of MongoDB Atlas. Link in the description below. It's free. There's no trial period. As long as you're under the data cap, you're fine. It's amazing. You should check out my colleague, Lauren Schaefer. She did an amazing series on MongoDB design anti-patterns, which tells you what not to do. Link in the description below. Be sure to like, comment, and follow for more content like this. Let us know. We'd love to make more for you.
So, and now you have seen this was my avatar. It was me in real? No. This was a short introduction to, and now because now I can skip all this.
Welcome. How's your afternoon going so far?
Your YouTube is still open.
Great. All right, next up we have he is a software engineer.
Oh, thanks. Okay. The important thing we heard now, not we read, we heard it. He told us your data model should fit to your application, to your need, and not different way. And this is one of the biggest advantages or disadvantages. It depends on when you are coming from RDBs. Sorry, not an easy word. This is the big difference. Model your data for the needs of your application, and normally it depends on read velocity or write velocity or whatever the need of your application is, and even the structure of your data has to fit your needs. So it has to be tailored exactly to what you need and not gain on no duplicate data and normal forms up to whatever. Forget it. This will not fit for MongoDB. MongoDB is not made for that. And this is the thing you can, when you're doing data modeling, you can follow these steps. The first thing is identify entities. What entities you need. Of course, that's more or less the same with RDBs. I say RDBs, not relational database, so I can't say this word. And the second thing is think about workload. So how often do you read this data? And in which combination you need this data for your application? This is the big difference. And of course you have relationships and there are some patterns, and I will give you a link to these MongoDB patterns afterwards. One thing, but in the video this is already mentioned about embedding versus referencing. I wanted to work this a little bit out, but I think it's enough. So we'll come to what we have done. Yeah, this is also one, sorry, this is an important point for using MongoDB is the flexible data modeling with MongoDB Atlas, because when you have tables and columns, it's not so easy to update them or extend them. You have always to migrate databases and whatever, and that time you have mostly downtime, but not for MongoDB. In MongoDB you can extend an attribute, for example, into a column, a collection, and it's there. The only thing you have to keep in mind is these new fields don't have to be needed when you are reading data, because when you are reading old data, this attribute isn't in there, and you will crash. The program will crash. So you have to be careful, but it's possible. Yep. Here's the link to the design patterns. And now the most important thing, because this is what I really wanted to tell you, the project experience is what we did with MongoDB. So it's a journey. Amelie, you can sit down. Thank you for your support. So I will take you to this journey through our project we did there. It was at Helvetia project, and we had to rebuild the existing application. The application is made to, let's say, I have to explain it in English, it's not that easy. Sorry?
It's easy.
Huh?
It's easy.
What?
It's easy. I mean, it's just an insurance certificate.
Yeah. Yeah, okay. But there's also this communication with the government, and
many parties are involved to
when you want to have a plate for your car, you have to have an insurance, because without insurance you will not get the plate in Switzerland. So when you are going to the government and asking for the plate, they will ask you for the insurance. But the good thing is there's an electronic way to send them the certificate that you can, that they know you are insured, or your car has to be insured, or something like that. And the old system was about 15 or 20 years old, so we have to replace that. And we replaced it with completely new technology. Wow! We used MongoDB, Java, Quarkus, Kafka, AWS.
Yeah, MongoDB.
Yeah. The challenge was we had to deal with, of course, it has to be fast, so performance is an important thing, and the amount of data is growing. It's growing on one day approximately between 2,000 and 3,000 documents on working day, yeah. And there are the automation level has to be hit. Of course, reporting, and there has to be an API for connecting or receiving data from external systems within the Helvetia, the company. And we did our data model as mentioned before. We put everything in one structure. So at first this was a good idea, but in some seldom combinations it was not. I will tell you why. So we have a plate. The plate has, of course, the canton and the number. So it's the plate of for the car. And then we decided to have states, because the plate can have is mounted on the car or not. Let's say it like that. The first thing, it's in German it's called EVN. It's elektronischer Versicherungsnachweis. This is the certificate, and this is the first thing what happens, because the customer is coming to the company, and he is asking for this certificate, and the Helvetia guy is typing this into the system, and of course the data of the car, the data of the customer, and everything else needed, and then he's sending this via SOAP service to the government. So this is the EVN. And when everything went fine, we get a number back from the government, and this is stored in this state structure. This was the first part. Second part is the customer, of course, he wants to drive the car, but for this he needs the plate. So he will go to the government and tell them, hey, I want to drive. Give me the plate. And on the government, they will take a look into their systems, and they say, okay, everything's there. So the data have been sent to them, and they will find him. They will handle him out the plate. And after this, they will send to the company, to Helvetia, the so-called IV. So it's Inverkehrssetzung, because the insurance company has to know the plate is taken, and at the moment the plate is taken, the customer can drive the car, because he has to be insured, the insurance to the car. So, and this is these are two documents we already have. So there's the EVN and the IV. And of course, some customers don't want their car anymore. What they have to do, they have to park the car on a place where it's allowed, of course, and take the plate and bring the plate back to the government. And after this, they will handle out the plate, and the government will send us the AV message. It's Außenverkehrssetzung in German, so that the insurance company knows, okay, customer Peter is not driving anymore this car with this plate. And this also means the insurance has to stop. So I hope this was understandable. This is the business case. But you can imagine there are companies, for example, and companies, they can use their plates for many cars. And of course they are doing it. And this is the reason the idea with this state is not good for every case. Normally you have one plate and let's say 5 or 6 different states. But there are companies, and we have one company with more than 1,000 states. And that's too much. Because it's on one side it's too much because of the database size. It's the 64 kilobyte border, and on the other hand it's too much for how we did it in the application, because at least we are loading the whole document to the browser. It's a online application, and sorry. And that's even too much for the browser, because the browser is running out of memory. At the moment we haven't fixed that problem, because it's only, there are really few customers having this problem.
But this was done in a float application before in .NET, no? When I was still there, the project. This case, this edge case.
Yeah.
It was in float, no? It's not a float insurance somehow?
No, it's already there.
Okay.
And but we solved it in let's say crazy way, but it's an easy way, because we decided to do a second plate with the same canton and number, but the different state, and this also works when the other plate has to be außer Verkehr. So the state of the plate is not, this means the plate isn't used anymore, we have all data, and the new plate is used. So we can handle it at least, but it's a disadvantage from doing it like we did it here. Of course, there are other collections, but this is the main collection. This is the business case of this application, and this is also the reason why we put everything in this structure for readability. Because when we want to read the plate, we have one read, and everything's in memory. I can tell you afterwards. There are some disadvantages too. As I told you before, we implemented with Java, Quarkus, Kafka, Atlas, MongoDB, AWS, OpenShift, microservices, and the other important thing is reactive programming. I don't know if you know something about reactive programming. Reactive programming means, for example, we don't have transactions. We don't use transactions in the completely in the complete application. We don't use them. We don't need them because of reactive programming. Reactive programming, it's Java with Lambda, and oh, I forgot to write it there. It's the basis of Quarkus. Quarkus is the follower of JBoss. It's from Red Hat, and they used. So this is why it's not written there. I can tell you afterwards the name of the framework. There's a special framework for doing reactive programming in Quarkus. It's the base of Quarkus, and it's fantastic using it. When you're using reactive programming, you need less memory, less CPU, and it scales horizontal. And this is what we need in the microservice architecture on AWS we choose.
But you should say it's only working if you have stateless microservice, which you can scale horizontally in the cloud.
Yeah. That's right.
Should be in the message, so
that's right, Cedric. But on the other hand, I must tell you the problem with scaling horizontal on microservice, so as we did it. Yeah, the problem is the pod needs too long to start.
I remember,
yeah, and it's still like that. When you are trying to do it like this, you need pre-compilation, and of course the main reason why this doesn't work very proper is the liveness probe and everything, because it takes too long for the pod. The pod is starting up, that's fast with Quarkus and everything, but then the liveness probe is checking for the database, is checking for blah and blah and blah, and this takes too long. So at least it takes more than half a minute that the pod is up and running, and that's not suitable for the need. And when the load is too high, but at least I can tell you, we never had problems with the load. Normally we are using 2 pods. They are spread to different clusters because of balancing, and when one cluster is going down, the other is taking the load, is overtaking the load, and this works really fine. There's absolutely no problem. But horizontal scaling on pod or with pods is not that easy as it sounds like, I can tell you. So we decided to do it with reactive programming, and that works fine. We never had a problem with that.
We did not do it everywhere, but we did it in a lot of space where there is batches, because then it's really efficient.
Mm-hmm.
Memory-wise.
Yep. Okay, and here are the problems we've got. Of course, we had so-called lost updates. But it was we did it. Because we didn't know it better that time. We've got lost updates because of our mechanism how to update displayed structure. Because when we have to update whatever in this plate structure, we read the complete plate structure into the memory. We manipulated data into memory and wrote everything back to database. And the problem was, there are cases, for example, when in the night these EV and AV messages are coming and they have to be processed, and they are coming independently. And we don't know when, because it's at least it's a Kafka message, and Kafka is also reactive, and it's not synchronized. And so the IV message, for example, was processed, and the AV message is also at the same time coming and will be processed, the last win, because, as I told you before, we don't have transactions. At least we solved this on Kafka. We used the same ID for these messages, and then it's in raw, it's serialized. And this cannot happen anymore. This is one thing, and on the other hand, we also are working on rewriting the updates into the application, but there are a lot of updates, and because we are rewriting them in the manner to update only the fields you need to update. For example, in SQL, you would never have the idea to update everything. The whole structure will never do it, because it's crazy at least. But that time it was easy for us, and the technology was new for us, and that's the reason why we did it. Of course, huge documents I already mentioned, and there's another thing, the amount of indexes. Because of this structure, wait, I will go back because of this structure, for example, when we have canton number and the vehicle has a so-called Stammnummer, there is an identical number which identifies every vehicle, and there's in German it's the holder, Halter. It's the person who is responsible for this car. And when you want to select these data, for example, by name, address, or whatever, you have to have indices on all these data. And because the data structure is that big, you also have to have indices. At the moment we have 45 indices, but we managed to reduce the amount of indices because at the beginning we had more than, or we tried to have more than 64 indices, but as you have seen, it's not possible. On the other hand, there's the disadvantage of having too much indices is the memory size. Atlas MongoDB tries to have all indices in memory. And as you can mention, there are 5 million plates in the database, and all these indices in memory with all these structures, it's too much.
Why you have 5 million? Because you don't have 5 million customers.
Yeah, there are also old data in. Plates can be reused, and only because of that, we already decided to delete some old data. But at the moment we didn't have deleted everything. So it's an ongoing process, but we have to do it. That's true. But anyway, even when there are only 2 million plates in, it's also a huge amount of indices and a huge amount of memory you need. Oops, here. As I mentioned before, that time the technology we used was completely new for us. So that's also not the best way to do a super fine application when everything's new. And so it's at least the experiences we made for the development and of course for the operations. In our company, we are doing DevOps the whole time, so we are responsible for development and operations. And this is one really big advantage of MongoDB I really like, is as I told you before, we never had downtime for MongoDB as far as I remember. The only downtime we had was because of the network. But this was Helvetia related and not MongoDB related. And yep.
How many years does this application have?
It's running since 2020 or beginning of 21. Okay. So at least 4 years. And it's absolutely, I appreciate that.
3,000 mutations per day is nothing. 3,000.
Yeah.
What is the total size of the database in this?
It's huge. It's huge because...
what is huge? 1 tera, 2 teras?
No, but it's quite huge because we import every night with batches data from the host into the content. We duplicate data. So we produce, I think I did it, I produce, I don't know, many Kafka messages, and then they are... Yeah. So the size, you have the size now after 3 years?
Wait, I can tell you. Wait.
More or less.
Good.
Well,
So it's on the cloud?
I can tell you. Wait,
okay.
Wait just a moment.
I was asking if it is on the cloud. You are using
Atlas? It's Atlas.
Okay.
Yeah. For another company, I made a presentation about Atlas versus Azure versus premise.
For the very right.
Another time, it was cheaper to make it on premise. Yeah. Because it was a small company and still growing, so Atlas was quite already a huge ticket. But for Helvetia, Atlas was a no question, no brain question. So I don't want to do the ops, so...
So, at the moment, we are approximately in production. Yeah, this is approximately by 10 giga.
No, 80.
But wait.
This 36 is the usage.
Blah.
It was on the screen before you saw
But
the
that's the
usage.
size of the machines. This we don't care. It's this.
Yeah, that's true.
Machines. You need to go to the replica set size, not here. That's the machines. That's just.
I was just curious about it.
It was still a lot of messages produced and stuff. So yeah. I think it's big, but not in.
Disk usage, the very right.
Aha, here, yeah, that's true. Yeah, because I never take care of the disk size. Ah, here, disk usage 36 gigabyte. Here you can see it.
Yes. Thank you.
But-
the TTL,
Someone is not
the deletion of the deletion of data is still a huge topic.
Ah, the pizza. The pizza! Hey, that's fine. Thank you. And here you can see the replica sets, as Juan before mentioned. And normally you have 3 replica sets. We used 4 because there's a special reason for that. Because there's one, let's say other way. Here you see the primary. The primary is the replica set we are working on. So every update, read operation, blah, is going to the primary replica set. The others, the secondary and third replica set, only backups, and they are the data are coming from the so-called op log, the operations log, and the operations log is transferring data to the other replica sets, and we have the fourth.
For analytics, no?
Yeah, and this is because of reporting, because we don't want to influence the normal working of the application. We decided to have a 4th replica only for reading data, and therefore it doesn't matter if data are updated 1 second or 2 seconds after they are written. We doesn't care about that, but we don't influence the normal process of the application. And since MongoDB 7, I guess, MongoDB 7 or 8, you can have your own indices on this special hey, this is an MongoDB. Yeah. Yeah, you can have your own indices on this replica, on this one. Yeah, and more or less I'm finished now. So you can ask now. Please give me your questions. I try to answer them.
Do you have there the interface for the application?
Sorry?
Can you show the interface of the
This is-
application?
Yeah,
this is
of
the
course.
database side.
Yeah. Sorry.
Yeah, it's
Because I'm just curious.
Yeah.
an Angular 3 with GraphQL, which is, and they did a library at Helvetia to have a reusable component. The application was not written by me and Peter and Stefan and Felix, somebody else, highly optimized, and so it has the CI/CD of Helvetia, blah blah blah. But at the end of the day, we did some query microservice for the front end. So the front end goes to special microservice, which are responsible to deliver the data, and then it's a GraphQL.
Okay. Sorry.
You can show it, yeah.
Yeah. But
Like an insurance application where you can search for a car and search for.
There's an issue on the application right now.
If you don't have it,
No.
I was just curious about it.
No.
Code and everything.
It's working.
In fact, every insurance company has the same application in some way. AXA has also an IFOM, and nobody on the market has the same application.
Okay. No, I'm sorry, I can't show it the application.
Done it once and make it open source and say everybody profit from it. There is no business advantage to have your own IFOM in-house.
Yeah, exactly.
So it's a bit. I never understood that part, to be honest, because I say, what is a business value? Nothing.
It's because of Nginx. No, it's not working. Hey, what's going on there?
You have access to
No, Cedric, the problem is the header size is too small in Nginx. We have to reconfigure it, and it's not rolled out to every stage at the moment. So it's only on dev stage and not on integration, and of course not on production. So at the moment, my user is not able to access the production. That's not good.
Okay, it's a good way to deal with the hackers.
He's responsible for DevOps, so we have access to everything.
Yeah.
We're responsible.
You should not say that.
Yeah, this is an ongoing discussion, I guess.
Then you also control the cleaning lady, that she's not putting a keylogger in the keyboard.
No, then you can do everything.
Yeah, of course, but I can do anyway everything because I have the access to the database directly. So,
Kafka messaging.
Yeah, even to Kafka.
Yeah.
I can do everything also on Kafka.
Yeah, but not read the messages. You told me for many months. You have no access to the Kafka messaging prod yet? No, you have it. Okay, good. Yeah, we need it. As developer, you need everything.
Yeah, because when there is a problem, how can I solve it when I don't see anything?
Give me the message with ID, blah, blah,
Your
blah.
luck is that you are not dealing with cryptocurrencies else.
Yeah, of course, it depends what kind of data are there.
Not financial,
Yeah.
But this is funny because it's a message sent to an external company called Bedark, and all Straßenverkehr are connecting, and I mean it's a huge ecosystem for just for saying, yeah, it's insured, or yes, a car is retired from the streets. You know.
Oh, good, nice.
So, okay. So far, so as you mentioned, I'm not a professional speaker, and I hope it wasn't too boring.
Practice gets better.
Yeah, I'm trying. I'm learning. It's not easy.
It's easy to speak publicly.
Okay, so
Nice.
then the closing. No, can you tell me what's all this about?
Not really, because
I have no idea because it's in the
it's in the slides.
yeah.
I don't know.
Find
Really.
open roles. No, it's written, no.
Somebody prepared those slides, most probably Hashid. Or,
Yeah, Hashid did it,
yeah.
but
So, I don't know.
I left them in because I have no idea. But sign up for community, or sign up for community. But I'm not sure if this works. Yeah, I'm sorry. Yeah. Okay.